So for this last example, we have a very long process and a very tedious one. We have x to x cubed plus 2x plus e to the x times x minus 1 over square root of x. So there's two ways to do this. We can combine these products in the numerator over square root of x and do it first as a product rule and then using the quotient rule, or we can first take the derivative of this using the quotient rule and then treat it as a product rule. I did both processes, and doing it as a quotient rule and then as a product rule is a little bit faster and easier to do. So let's do it. So we're gonna take the derivative of this one using the quotient rule. And then we're going to take the derivative as a whole using the product rule. So I'm going to do the quotient rule first in a separate sheet of paper. So let's call this one g of x. So we have x minus 1 over square root of x. This is quotient rule, right? Quotient rule. So let's set it up. G of x. So we have d over dx, x minus 1. I'm going to rewrite square root of x as x to the 1/2. You'll see why in a bit. Minus x minus 1 d over dx of x to the 1/2, and then all of this over square root of x squared. So we have x minus 1, the derivative is just 1, and then we have x to the 1/2 minus x minus 1. Then we know that the derivative of x to the 1/2 is just 1 over 2 x to the 1/2. And then all of this, as we know. And then square root of x squared is just x. So we're gonna have over x. Now it's time to split the fraction up. We have one over here, and then we have the other one over here. So let's split it up. So we have x to the 1/2 over x, x to the 1/2 over x minus x minus 1 over 2 x to the 1/2. I just combine this with this, and then since we have x, we flip it, 1 over x. I'm going to rewrite x, so we have x to the 1 power, but since we have here x to the 1/2, to have it all in the same base and powers, we're gonna write it as x to the 2 over 2. It's the same exact thing, x to the 1, x to the 2 over 2, 1. So we're gonna have x to the 1/2 over x minus 1 over 2 x to the 1/2 x to the 2 over 2. This x to the 1/2 x to the 2 over 2 is x to the 3 over 2, but I left it this way. You'll see why. So now we learned from algebraic fractions when we had 1 over a, 1 over b. This is b minus a over ab. We're gonna do this process over here. So what am I missing in this fraction to have the same denominator? Oh, I'm also writing this x to the 2 over 2, x to the 1. So to have the same denominator, I'm missing a 2, and I'm missing an x to the 1/2. So I'm going to multiply 2 x to the 1/2 on the numerator and on the denominator. So we have 2x to the 1/2, and then 2x to the 1/2. So now I have the same denominators, I can combine them. So we're gonna have 2x to the 1/2, x to the 1/2, minus x plus 1. This negative is affecting these things. And then we have over 2x to the 3/2, because 1/2 plus 2/2 is 3/2. We have 2x to the 3/2. So, and then we have to add these things. 1/2 plus 1/2 is 2/2. 1. So we have 2x minus x plus 1 over 2x to the 3/2. So this all simplifies to x plus 1 over 2x 3/2. We did the first step. The only thing I did here is I just solved the derivative of this part over here. I haven't touched the other part. So now we know this. We know the derivative of this is x plus 1 over 2x to the 3/2. Let's keep it away, and then now let's do the other part. So since I know the derivative of this already, I can set up my product rule. So I'm going to set it up. F prime of x, sorry, is going to be d over dx. I'm going to zoom in a little bit. D over dx of x to the 3rd power plus 2x plus e to the x times, let's see, times x minus 1 over square root of x plus x to the 3rd power plus 2x plus e to the x times the derivative of x minus 1 over square root of x. We know this already. This one is the same as this one. So we know that already. This makes the work a little bit easier. So let's see, I have my notes over here. So let's apply the derivative. So we have this derivative is going to be 3x squared plus 2x plus 2 plus e to the x times x minus 1 over x to the 1/2. I rewrite this, you'll see why. In fact, we can put all of this under the same denominator, this part over here, and then we have plus x to the 3rd plus 2x plus e to the x, and then times the derivative of this, which we know. We're going to copy it right here. We have x plus 1 over 2 times x to the 3/2. Right? So I'm going to put this in a way you can see it more clearly. So we have 3x squared plus 2 plus e to the x times x minus 1 over x to the 1/2 plus x cubed plus 2x plus e to the x times x plus 1 over 2x to the 3/2. So we're almost done. We have different denominators, so we're going to do the same process as last time. I'm going to, so I can rewrite this x to the 3/2. I'm going to rewrite this as x 1/2 x 2/2. So now we're going to do the same thing. What am I missing here to make the denominators the same. I'm missing a 2 and I'm missing an x to the 2 over 2. So I'm going to multiply here in this fraction to make it equal. I'm going to multiply 2x2 over 2, 2x2 over 2. So we're gonna have the same denominator, 2x to the 3 halves. Sorry, this is a long problem. So here in the numerator we're gonna have 2x, this is the same 2x to the 2 over 2, 2 over 2 is 1, times 3x squared plus 2 plus e to the x times x minus 1 plus x to the third plus 2x plus e to the x plus 1. And then all of this over the same denominator of 2x to the 3 halves. So let me see over here this next step. So the next step I'm going to do is just going to be to distribute this in these 3 terms, and yes, we're gonna do it. So I'm going to get another paper. I ran out of paper already, so we're going to distribute now. We're going to distribute. So now 2x times 3x squared, that's going to be 6x to the third, yes, 6x to the third. And then we have 2x times 2, we're going to have 4x. And then we're going to have 2x times e to the x, that's going to be 2x e to the x, right? And then times x minus 1, I don't know why I switched colors, but it doesn't matter. So we have, and then we're going to multiply this times this, this times this, and then here and here. We're going to apply this distributive property, but we're going to do it later. We're going to write it as it is now to make things easier and clear. X plus 1 over 2x to the 3 halves. The only thing I did over here, I just multiplied this 2x with this. So now we're going to multiply this x minus 1 with this. So we're going to have 6x3 times x, we're going to have 6x to the 4th plus 4x squared plus then 2x e to the x times x is going to be plus 2x squared e to the x. And then we have the minus 1, we're going to have minus 6x3 minus 4x minus 2x e to the x, right? We're going to have minus 2x e to the x. Yes, and then I'm going to multiply this times this. I'm going to this one in the same color. So I'm going to have plus x to the 4th plus 2x squared. I'm going a little bit more faster here. Then here, here, and here. Then the plus 1 to all of them. Plus x e to the x plus x to the third, sorry, plus 2x plus e to the x. I'm running out of space. And then we have it, all of it over 2x to the 3 halves. So now it's time to combine some like terms. I'm going to use as much color as possible. We have this with this over here. I have 4x squared and I have 2x squared. I have another one, minus 6x to the third, and then I have plus x to the third. And let's see, we have another one here. We have another one. We have minus 4x plus 2x. And I think that's all of them. So I'm going to do this in the same color. We have 6x to the 4th plus x to the 4th is going to be 7x to the 4th. 4x squared plus 2x squared is going to be 6x squared. And then we have 2x e to the x. We don't have any other terms, so we're gonna leave it. 2x squared e to the x. We have minus 6x to the third, and we have a plus x to the third. That's minus 5x to the third. Then we have minus 4x plus 2x. That's minus 2x. And then we have this plus x e to the x, and then we have plus e to the x. And then all of this over 2x to the 3 halves. Now we're almost done. So to make this simpler, we're gonna simplify it. We're gonna do factoring by grouping. We have, so what do I mean by grouping? We have, let's see, we have e to the x term, we have e to the x term, and we have e to the x term. Yes? Oh, I forgot another term we had here. Minus 2e to the x, and we have plus x e to the x. So minus 2 plus 1 is minus 1. So this becomes, this is not positive, this is negative, plus minus x e to the x. Sorry. So we're gonna group this thing up. We're gonna group all the terms that have e to the x. So we're going to have 2x squared e to the x plus x e to the x plus e to the x plus 7x to the 4th plus, and then I'm going to add all of these terms remaining, plus 6x squared minus 5x to the 3rd minus 2x over 2x to the 3 halves. Now just 2 more steps. I'm going to take out the e to the x of these terms. Yes. So we're gonna have e to the x times 2x squared, right? And then we have, this is a minus 9, minus x plus 1, right? That's what is remaining. And then we have plus 7 x to the 4th minus 5x to the 3rd plus 6x squared minus 2x. All of this over 2x to the 3 halves. And then I think that is it. Yes, that is the final answer. So f prime of x is this big massive thing over here. And to be sure of this, I did it on the graphing calculator. So I have here in the bottom, we have the same function as we started. Let me look for it. We have the function. Yes, we have the function here. I have it here. I used the function of the calculator, and I found out the slope of the tangent line when x equals 1, and it says 5.71. And then I used our result here, this result, when x equals 1, and if you let it, all these x's equals to 1, you're gonna have this over here, and it's also 5.71. So we had the same result. This is the derivative of that big expression over there. I hope you understood it.